This lecture looks at a review of the Solow growth model. You should watch other videos to get at the fundamental building blocks of the Solow growth model. This is just a review in quick format. So the first thing to remember is the focus here is on capital accumulation. As a result, we de-emphasize labor, but we're interested in GDP per capita, which we often approximate as GDP per worker, because the capita, the people in the economy, and the number of workers are closely related, and we're interested in the long run. These are long run models looking at over a long period of time. So we're not looking at fluctuations in unemployment and so on. So really we can focus on this. So if we're going to focus on that, we may as well just write the whole model in terms of that. We start by taking the Cobb-Douglas production function and dividing the whole thing by labor. When I do that, on this side, I get A, K, alpha, L1 minus alpha over L. This is 1 minus alpha minus 1. This gives me A, K, alpha, L minus alpha. This is the same thing as that. We have this over here. So I define two variables, little y as GDP per labor and little k as capital per worker or per labor. And I can write the whole thing like this. That is my Cobb-Douglas production function in terms of workers. So output per worker, technology, capital stock per worker, and this is the capital's share of output. So we now have a production function that looks like this. We take our normal national income identity. We look at a closed economy, so we make this 0. We're ignoring the role of government for the moment. So this is 0. So this really is C plus I. Again, we want everything in terms of labor. So I call this little c and this little I. This was little y. So we have little y equals c plus I. I'll write that over here. Notice y is just broken into these two things. So any income you get either goes to consumption or it goes to investment. How much goes into investment is how much you're saving. So we define a savings rate, and so y basically gets broken into the amount you save. So 10% of my total income is I, or what I don't save is C. So I have two additional little equations that emerge. One is that investment in this economy is S times Y, and the other is that consumption is 1 minus S times Y. These are basically our fundamental equations. We graph this and we focus on the steady state. The steady state is defined as when capital is constant. And to look at that, we need a capital accumulation equation, the last official important equation. And that is the change in capital is our investment. Minus delta KT. That's also sloppy. Let me redraw that. So what this says is capital per worker. In the future, it's growing at a rate of investment minus what's depreciating. This is adding to our capital stock, investment, This is depreciating our capital stock. It's falling apart. When investment is just equal to this, these two equal 0, and we are called in steady state. We graph that using a graph like this, where we first graph this line, and then we graph this line. This looks like that because this looks like that as long as alpha is less than 1. So this is just some fraction of that. Where those two cross is where these things are equal, and we have what we call our steady state level of capital. In brief, if we're here, investment is greater than depreciation, and we move back towards steady state. And if we're here, depreciation is greater than investment, so our capital stock declines and moves us towards steady state. So we're always pulled back to that same steady state.